There's also seats. So, hola, bom dia. I will start now. My name is Timo Drick. I'm Android developer at 7 Principles, and I will demystify pixel shaders today. I live in Frankfurt, in Germany, and I'm Android developer full-time since 2010. And now, I give you a short introduction to shaders, what shaders are. By the way, there's a QR code, and you can scan it, and there are all slides, so you can watch the slides also in the net. So I give first a short introduction to shaders, and then I will show you how to use shaders in Compose. And then we go a little bit more into details of shaders, how to draw shapes with shaders, and then later animations. And I will also show a little bit more about how you can develop shaders and how it works in the engineering process. And then I give a short summary. So let's start. First, some samples. What can you do with shaders? So here you see a normal app, and the background is drawn by a shader, this triangles and this light things. And here's another example of this wave lines in the background. This is also drawn by a shader. Here's another background. This is one of the sample apps of the Android Google developers, this sample Compose app, Jet-lagged. You find the source code also. By the way, all the samples I show you today, the source code is available. When you look into the slides, there are links, so you can find everything. And when you look closely here, the background is also animated. You can also, for example, animate your buttons with shaders. The shine animation is done by a shader. So maybe when you have a button which you want the user to click or at least get the attention to, then you can do some animations here. Or you can do loading animations like this with shaders. Also maybe, you want to program in AI. I think everyone does this today, right? So, but how can you visualize this AI? You can also use a shader for this. Anyone knows, recognizes animation? Which AI could it be? Yeah, okay. I learned that someone does not know Kit, so it's a series from the 80s, I think, with David Hasselhoff, so maybe you can Google later for it, yeah? But the older guys know this. We can also go crazy with shaders. For example, you can make the button really hot, so maybe the user touch it or do not touch it. Or you can also do the 3D stuff with shaders, yeah. Or also transition animations like this certain animation. So when you want to a transition between one composable to the other. So let's talk a bit about the theory. So shaders are almost used in every graphics pipeline nowadays. So even the very old Android devices do have graphics cards inside. And today my talk is about AGSL. It's Android Graphics Shading Language. And it was introduced in Android 13. And the new thing now, what you can do with it is create custom shaders. Shaders are also used in games a lot. And normally you know it from OpenGL and Metal. Metal is this OpenGL from Apple. Yeah, they have their own standard for macOS and iOS, and of course also WebGL. One important thing, the code of the shaders will get compiled and executed on the graphics card. So It's not the same like Java or Kotlin code. It's very fast. Yeah, but we will see. So maybe you also know how to draw something with Compose, or also with the legacy view system. By the way, everything with shaders today, it works also with the legacy view system, but my samples are only for Compose. So for example, when you want to draw a circle with the normal draw canvas API, then you can fill it with a solid color, or you can use a linear gradient, yeah, which is also one type of shader. Yeah, very simple one, of course, or a radial gradient, or you can use an image as a texture for the shader. But today we will have a look at the custom shaders. And yeah, unfortunately, it's a complete separate language. It's not Kotlin or Java. So you have to learn a new language. It's similar, it's like C, some kind of C. But yeah, as you can see here, we define one main function. And this function gets as an input the coordinates of a pixel on the screen, and it has to return the color. And that's all. So it's very simple. You just get x, y coordinates of the pixel on the screen, and you return the color. And the graphics card will then run this function in parallel for every pixel on the screen. It depends, of course, on how large your screen is. And you return an RGB value, so for red, green, blue, and an alpha channel. And yeah, as you maybe already noticed a little bit, we do have here this float 4 and float 2 types. And it's kind of a vector or yeah, an array in Kotlin or Java. So this means here there are two values inside of this fraccord variable then. So and the first one is x and the second one is the y. And the return value is a float of 4. And there you specify the red, green, blue channel and the alpha channel for the color. And yeah, here it's 1.0 is a full value. It goes from 0 to 1. So in this case here, it's red. So for the red channel, it's full. And for the other channels, it's 0, so no color. And the alpha channel is 1, so it occupies the background. And then the result would be this just red rectangle. Yeah, very boring. But it will get better. So for example, let's assume that this rectangle is exactly 200 pixels in width. And now, for example, when we want to do a linear gradient, we could divide the actual x coordinate from the pixel by 200. And then this value would go from 0 to 1 from the left to the right here. So here again, the data types. So this float 2, you already see. So you can directly access the different parts from this with .x and .y. There's also float 3, then you get the z for this. And for this alpha channel, you get this .w here when you use a float 4. Yeah, for colors, x, y, z is not so good, but you can also use RGB and A to access the components. It does not make a difference, so you can do it how you want. Okay, so now how we can integrate this in our Compose app. So here we see as a string the shader code. So you just can create a string. And when you use this add language annotation here with AGSL, then you get also syntax highlighting from Android Studio. So it then looks a little bit nicer. And when you have the string here, you can create a modifier to show your shader. And here I use this draw with cache. This is not a new API. This is just the normal composed API for drawing on canvas. The new one is this runtime shader here. This was introduced in Android 13. And you give the shader source as a parameter to the constructor. And then you can create a brush out of it. And this brush you can then use in your draw method here. And in this case, I just draw a rectangular with this brush. When you do not provide any parameters for the rectangle, then it will fill the whole screen or the size of the canvas. And yeah, here it's the code again. And then when you want to integrate it in a composable, like your screen, then you can create, for example, a box and add this background shader modifier here. And then the output would look like this. Yeah, still a little bit boring. It's just a red background now. But we are able now to change the shader. So now maybe, I showed you this linear gradient with the 200 pixels width, but yeah, you don't know how the width of your rectangle may be. So we can use uniforms to transfer some data from our compose code to the shader. And here's an example to get the size of our canvas into the shader code. And here you see in line 2, I modified the shader code, so it gets here a uniform float 2 size. And I use this size then here. And in the Kotlin code, you can just use this shader set float uniform. And then here the name, of course, the size must match the variable name inside of your shader code. And then you provide the 2 floating point values. You can also use float 3 or 4, then you have to provide more parameters here. And yeah, then I modified the code a little bit, so it will the x coordinate will be divided by this the width of the canvas. So then the linear gradient will adapt to the width of your view. Okay, so next topic. Yeah, it's a little boring just to do some linear gradients or something like that. Maybe we want to draw a little bit more shape. So for this, because we get the pixel coordinate and need to return a color, it's not possible to just have some methods like draw a line from point 1 to point 2. We have to do everything, the math from scratch on our own. But it's not so complicated because at the end we just need a distance function. So that we know when we have the coordinates of the pixel, where we are, we need to know the distance to the shape outline. And yeah, one simple sample is just using a circle. And the distance to the circle is just the vector distance between 2 points, or the length of a vector. Fortunately, in the shader language, we do have a function for this already built in, and it's called length. And we have to provide a vector to it. And to calculate the distance, we just subtract the position from this coordinate. And in this case, I want to draw a circle at the center of this canvas. So I used now, let's assume the canvas is exactly 200 by 200. So my circle will be at position 100, 100. And now I can calculate the distance by just subtracting the circle position, so this is the midpoint from the coordinate. And so that it's not a tiny point, I subtract the radius of the circle, and then I get the distance. So this is this d value. And now to calculate the color, I can just check if it's smaller than 0 or bigger than 0. And depending on this, I use white or black in this case, but of course you can use any color. And just return it. Sorry. Maybe one thing you notice here, the edges of the circle are very pixelated here. Yeah. It's not an error from my slides, or that's a bad resolution here. It's because of this function. And to get rid of the pixelated edges, we can use a smooth step function. This function you get, you provide a starting value and an end value, and the input value itself, and then it will return a value between 0 and 1. But it's not linear, so it will, at the beginning of this range, so you provide a range starting and end, and at the beginning of this range, it will slowly start to increase, and then later at the end, it will also do a smooth transition. Other thing we need is the mix function, so that we can mix two, you can mix anything, but we want to mix two colors together, so the background and the foreground color. And this is just a linear function between both values. Here is the mathematical function, but it's not so important that you know it. This mix function is also built in the shader code. And depending on the value you put in at this weight, it will completely use the component from A or B. And when it's between, for example, 0.5, then it will exactly mix both 50% by both parts, the color. And now we can change our code here. So first, here I introduce this smooth step function. And here I created a variable s for the size of this edge. And then in the smooth step function, I go from 0 to s and provide, and d is the actual value. Yeah. I have to subtract s from the radius, because otherwise my circle would be greater than the canvas and it would not fit here. And then I can mix the foreground and background color based on this smooth step function. Yeah? And here you see it's now very blurry, the edge, because I used 20 pixels as the range between, or as the size of the edge. Of course, I can now change the size. This is even bigger, then it's more blurry. And you can also reduce it. And then here you see it's not pixelated at the edges. Still a little bit blurry. You can also reduce it more, but then it gets pixelated again. So you need to try a little bit which value you need. Okay, so that was a circle. And of course, maybe you do not want only to draw circles. So you can draw different shapes. Here you see a rectangle, a triangle, or a hexagon, or a pie chart, something like that. And a great source to get these functions, the distance function for the different shapes, is from Inigo Quiles. and the link is here. As I said, everything is in the slides. Yeah. Okay. Now you know. I mean, in this on this page there are many more shapes. So it's just I just have provided some samples here. Yeah, there are more. And now maybe we want to combine different shapes together to create more advanced shapes out of it. So the good thing about this distance functions is that it's very easy now to combine different shapes. Yeah, for example, when we want to subtract two shapes from each other, here two circles, then we just use the maximum of the distance of both, but provide a minus here for the shape you want to subtract from the other. And union is also very easy. So when you combine two shapes together, here, this as example, then you just use the minimum of both distances. Also, intersections is easy, just the maximum without a minus here. Yeah, we can do other things, some kind of deformations, and yeah, and instead of changing the distance formula or the values from the shapes, we can deform our coordinate system. So, for example, when we want to move the shape for just in x and y coordinates, we can just add a vector to our coordinate system. Or when we multiply it, then we scale it. For example, here I move first my center point, my coordinate system, I move it to the center. So I subtract 100 by 100. This means that here at the center it's 0, 0, and at the left it will be minus 100, and here plus 100. And then I can multiply it here by, now for this, the x component, I use 2. This means that it will be stretched, yeah? And when we change it and multiply the y coordinate, then it will be shrink down here in this, and the width will stay the same. We can also rotate our coordinate system. I will not explain this formula, but maybe one important thing here, you notice a new data type, a mat2. It's a matrix, so it's 2 by 2 matrix. And you provide here an angle, and then you have this formula, and you get back a matrix, and then you can multiply this matrix by your coordinate system, and the coordinate system is then rotated. And now it's a little bit boring to rotate a circle because you will not see anything. So here I introduce a new function which creates just a rectangle. This is from this article from Inigo Quiles, so you can just look onto the web page from him. And I do the move the center position again here, the coordinate system to the center. Then when we want, for example, to rotate our rectangle by 45 degrees, we have to do a little bit of math because the angles must be provided in radians. So you can use this formula, or you can directly provide it in radians. And then, as you can see, I just multiplied my coordinate system by this matrix. So this rotate will return a 2 by 2 matrix. Yeah, and then, in this case, I also use the smooth step here to smoothen the edges a little bit and mix foreground to background. So now, still maybe you're thinking that's boring. What can I do with this? I want to show you one example now. Here, this is just using this function what I already showed to you. So it's just triangles, different colors, and smooth step function. It looks a little bit boring with this beamer here, but normally it's more smooth. The code for this is also, it can also provide you. Here I defined a triangle function. Also, I use this triangle function from Inigo Quiles. And I have here a rotation so that I can provide different parameters for rotation and the smooth step factor here. And then that's all what you need to create this background, for example. So it's just 31 lines of code. Okay, next topic, animations. How can we do animations? So let's create an animation shader. So first the compose code. In this case, I need some variables from compose. So in this case, the modifier, I use composed keyword here. So I can introduce here an animation variable from compose. So I use this infinite, I use this remember infinite transition and then create an animated float out of it. You can, of course, use different methods to create your variables, but for me, it's now the easiest to do it this way. So I just create a variable which gets a value from 0 to 1. And also important that you define this animation specification, that it will be, you can define the duration. In this example, it's 2 seconds. But important is this linear easing because otherwise the time gets distorted. So for me, in my shader, it's easiest to have a variable between 0 and 1 because it makes the math much easier and it's not distorted. So you already know this uniform thing. So now we provide also a uniform for our time. It's I time, and it's just this animation value. Compose will take care of everything and will refresh this variable on every frame of your composable. And here you see the code on the shader. It's almost the same like before, but now I have this uniform I time here, and I calculate an angle out of it, and in radians, 2 pi is 360 degrees, so I multiply it by 2 pi, and I use this minus because when you deform the coordinate system, it works all in reverse. So when I rotate clockwise, then it will, when I rotate the coordinate system clockwise, the shape itself will be rotated anti-clockwise. So I have to invert everything. Was still boring, but when we now play around a little bit and do a little bit more rectangles and not only one, we can get maybe a loading animation in this case. Here, this first line is to scale our coordinate system to values between -1 and 1, because then I do not have to change my shader code when the canvas size changes. So it will be scaled automatically. Here you see the angle calculation is the same. And now I use a for loop to draw many rectangles in this case. One thing to notice here is that in AGSL you cannot use any kind of for loop. You have to provide a constant value here as for this end point of the for loop. So yeah, you're a little bit limited. It's because it's backward compatible to very old versions of shader or of hardware, so it will work everywhere then. But yeah, as you can see here, I play around a little bit with these angles and rotate it. But I not draw directly the rectangles with this angle, but I just move the rectangle out of the center point a little bit, and then I use the angle to define an intensity, and use this intensity for my box, for the size of the box, and also for the smooth step. Yeah, and then I add all together. I also here, I clamp the values, so between 0 and 1. You can return values greater than 1 for colors, but yeah, then you get sometimes weird results. So in this case, I do not want it, so I clamp them, and then here I would return it. Yeah. Okay, one other animation, I showed you this shine animation, and here you see the code for the shine animation. It's a little bit simpler because I do not need to rotate my coordinate system. I can just deform it a little bit by, for example, here for my position, I add to the x coordinate, I add a factor of the y coordinate, and then it will be a little bit distorted to the right. And here I just use two smooth step functions for the starting edge of the shine animation and the end of the shine animation, and I subtract then the end. So I get brighter colors inside of this. Yeah, and then yeah, this is the same code. I use this highlight also for the alpha channel. This means that at this parts where the shine is not drawn, the background will be drawn. And yeah, I showed you this animation earlier. And now when you look closely, you see that's just rectangles and circles. So every one of you should be able to create it on your own now. Of course, the source code is provided if you want to see it, but yeah, in theory, you could do it on your own. Of course, you have to friggling a little bit around with the different variables and functions. Here's the code, by the way. It's very nice because it's just 31 lines of code for your shader, and that's all what you need. You don't need any libraries or something like that. Okay. Yeah, it's getting late. Now, how can we develop shaders? Problem when you you can change directly the code in your string variable, but every time when you do a mistake, then the app will crash. So it makes sense to catch errors during the development process at least. And then when you use it in Android Studio, yeah, you can just change your code. Here's a recording where I change it now. And here on this side, you see the preview from Android Studio, and here it's from the app. It's a running app on a device. And as you can see, when you have live editing on, when you change values here in your shader code, this is just a string variable, then it will instantly also update on the device and also in your preview of your code. So it works also in preview. It's very nice. And for example, also animations work on the device. But on the preview, you see there's no animation. But in theory, animations work in preview, but it will not start the animation automatically. So I have to do it manually. I can click here and then click on play. And then it will also animate. But when you change the code, it will stop again. So it's a little bit disturbing. When you do animations, maybe it's easier to use a real device in this case. Yeah. Here now I changed the alpha channel. And you can see now the background behind this. OK, so some words about compatibility. I already told you that, yeah, it's introduced in Android 13 or API level 33. So, yeah. Well, yeah, you need to make sure that your code is then executed only on devices which are newer. It's also supported in multi-platform, but there's a little bit different API, but the shader code will be exactly the same. And one important thing, AGSL is based on SKSL, and SKSL it's Skia shading language, and Android uses Skia to draw everything. To draw lines and buttons, everything on your UI. Also, this legacy view system uses Skia. It's a drawing library, a C-based drawing library. And Skia itself do have this SKSL. So Skia itself uses OpenGL to draw everything. And OpenGL has this GLSL, OpenGL shading language. So SKSL is based on GLSL. And this is supported on almost all devices, also very old devices. This is an important thing here. So when you want to provide backward compatibility, one thing could be just provide maybe a solid color as background in case when the version of the operating system is too low. But in theory, you could also use OpenGL to draw your shaders. Yeah? I'm working on some kind of wrapper around OpenGL so that you can use the same shader code I provided to you in an OpenGL shader. But there are some limitations. You cannot then use it as a modifier. But then it will also run on very old devices. So when it's very important for your app to show a shader, then maybe you can use this. Or maybe you have to yeah, it's just a prototype. So yeah, you have to maybe fix some problems when you get something. OK, so that's all. Now I will show you some more ideas what you can do with shaders here. For example, yeah, it's a pie animation in 3D, and it's also drawn by this AGSL shader. And when I move the device, the attitude of the device, when I turn it, then the shadow, for example, turns also. Another sample would be when you create an audio app, then you can draw this histogram by shaders. And you know what's this? How it's called? No, but this mascot from Google, how it's called? You don't know? Bug Droid. Yeah. Okay. Yeah. It's also simple shapes. Yeah. It's just circle here, half a circle, and yeah, here it's also some kind of circle. But you can also do it in 3D. And yeah, this is also AGSL code. Yeah, it's of course a little bit more complicated to do it in 3D. I will not go into details now, so we're running out of time. So just a short summary. So you can create amazing effects with AGSL. And when you use it, it's not used a lot currently, so your app will really stand out. But of course, yeah, it's very steep learning curve, so you have to learn a new language, and also, yeah, it's mentally a little bit different than drawing normal lines and using coordinates. So you have to use a different math. But it's very fast because it runs directly on the GPU and in parallel for every pixel. But when you just want to draw a circle or simple shapes with lines and do not want this gradients and smooth transitions, then maybe it's easier to use the draw calls from the normal Canvas API. Here are all references and source code samples. As I said, it's everything in the slides. You can look it up here on this web page, or you can scan this code. Okay, so obrigado for your attention. So yeah, do we have? Not sure. Do we have some time for questions? Okay, yeah. Yes?
You have shown previous stuff, but the code that you displayed was mostly equivalent to a pixel shader. Is there a vertex shader or geometry shader?
No, it's just the pixel shader, fragment shader, yeah.
So you have to simulate.
You cannot. Yeah, the CDs thing you mean? Yeah, I do ray matching, and yeah, it's simulated inside of the shader. But it's a little bit limited what you can do. Maybe when you want to do more crazy stuff, you should use OpenGL. Yeah. Yeah, maybe when you are interested in the 3D things, here's also good YouTube channels where you can get more information and learning more. And also this shadertoy.com webpage, there are very exciting samples, but not everything runs on the Android hardware. More questions? Yeah. Sorry, please, a little bit. Yeah.
Would it be possible to apply the shaders for a streaming video surface in order to make part of it transparent?
Yeah, it should be. It's a little bit tricky when you use these surface views, but maybe you have to use this texture view, then it should work.
In theory, Surface Flinger is handle this like it's nothing, right?
So when you use AGSL shader code, it's more embedded into the Compose view system, yeah. But you can draw it on top of a surface view on maybe another OpenGL view, or when you have a video, yeah, it's possible, yeah. It's like a normal button or something. It's like normal UI from Compose, yeah. Okay, anyone more? Yeah.
Would you recommend it for fluid simulations?
It depends how difficult it is, because it's also a little bit a problem to transfer a lot of data into the shader. Yeah, you can do it. I mean, I showed you this animation for this audio signal, and I used a bitmap to transfer data from my Kotlin code to the shader code. So it's a little bit tricky. You can do a lot of things, but it's not so straightforward. As I said, maybe when you want to do more complex thing and it's the main thing of your app, maybe you should use OpenGL for this. Yeah. Yeah. You're welcome. Anyone? Any more questions? Yeah, 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 of course.
Do you notice any battery issues when you use that? Does it last long? Is
Yeah.
it consuming more energy or even less energy? I don't know.
Not really. I mean, when you do animations, it takes a little bit more. And it depends also a little bit on your code. When it's too complicated, the code, then the main problem is that it will not be fluid, your animation. So it will only draw 10 frames per second or something like that. Yeah, that's then the problem. Yeah, in terms of battery, I don't think that it makes a big difference. Yeah, but of course, at the end, it will take a little bit more, I think. But I do not notice big differences there. Yep. Yep.
Since you're tapping directly into the drawing phase, skipping all the composables, the life cycle and everything, does it imply that somewhere you're going to hit your composition issues, or not at all?
When you do something wrong, maybe it will, when you do an animation, then maybe it will not animate correctly, yeah. When there's something wrong with the composition stuff, and Compose do not notice automatically that your animated variables will change, yeah. But normally, yeah, as I said, it's very well integrated into Compose. And also the old View system, so it's the same API. But yeah, I think it's, you don't have any problems, I think. But
yeah, because it's really you have to really be considerate when working with
yeah.
Compose, right?
But you can also use it not for animations, just for images or something, and then it will not render it again and again. When you do not change a variable, it will not render it again. Then it's also much less battery drain, maybe, yeah. But when you do animations, you have to change this animation variable on the right place. And when you do it directly in your Compose code, I think then you get also problems. But it's the normal Compose problems then, yeah. It's not related directly to this. Yeah, you're welcome. Okay. Okay, yeah, so thank you. Obrigado.
and thank you for joining. Well, my name is Nuno. I'm an Android developer at Critical TechWorks. If you don't know, we are a BMW joint venture to put together to build software for BMW. And in these 3 years, I've been working mainly in BMW's Android automotive infotainment systems. So we do cool stuff with Android, and that is actually how this session came about. So the plan for today is to demystify KSP. So you guys are probably already using libraries in your projects that support KSP. And if you're like me, you've probably wondered what is the black magic going on behind the scenes. So today we'll see exactly what that magic is all about. And we'll also learn that KSP is in fact a surprisingly simple API. My goal is that by the end of the session, you'll have the necessary tools to start using KSP in your projects and also conjure your own KSP magic. Okay, I must warn you that, however, we have a lot of ground to cover today, so we'll be moving quickly. Also, the code snippets that I'll show you are part of a working demo app, and at the end, I'll provide you the link so that you can dive into the code at your own pace and revisit everything that we'll talk about today. So, what's on today's menu? First, we'll start by seeing what KSP is and how to use it, and then the best way to really learn KSP is by actually using it. So, we will solve 3 practical problems with KSP, each with increasing complexity. These examples should cover everything that you need to get started with KSP, and let's now see what is KSP. If you go to JetBrains' website, it will tell you that it is an API to develop compiler plugins focused on Kotlin and with simplicity in mind. Let's dissect this in a bit more detail. So KSP is a tool to analyze and manipulate Kotlin code, which opens the door to implementing our own compile time tasks, such as code generation and code verification. It is also a faster and more efficient alternative to CAPT, in some cases up to twice as fast. And the big thing about KSP is that it understands Kotlin-specific features, such as top-level functions, extension functions, and more. Let's also see what is a compiler plugin. So, a compiler plugin is a metaprogramming tool that enhances our programming experience by extending the capabilities of the compiler. Plugins call the compiler directly as a library to analyze and in some cases even edit the original source code. The end goal is to usually create some output such as boilerplate code. As you can see, compiler plugins are pretty powerful things, but power usually comes at a price. So to develop a full-fledged compiler plugin, you usually need a lot of background knowledge on the compiler and on the specific compiler implementation. This means that your compiler plugin will often be tied to a specific compiler version. So if you want to update the compiler in your project, you will probably be forced to update your plugin. And the Compose compiler plugin is a prime example of this issue. But fortunately, KSP is different. KSP is designed to abstract the implementation details of the compiler so that you don't need to worry about changes across different compiler versions. Also, KSP is not tied to the JVM, so you can use it, for example, in Kotlin multi-platform projects. KSP also is focused on performance, and probably the biggest design decision behind KSP was to trade complexity or to trade the power of a full-fledged compiler plugin for simplicity. So KSP provides a simplified API, which is actually very similar to Kotlin Reflect. And the trade-offs are that with KSP, we cannot examine expression-level code nor modify the original source code. So we can only do additive transformations of the source code with KSP. These design decisions should, however, not deter you in any way from using KSP, as KSP is usually more than powerful enough for our applications, with, of course, the added benefit of a much gentler learning curve. And don't take my word for it. Trust all the popular libraries that currently support KSP, and this list is only increasing by the day. So let's have an overview on how to use KSP. We start by creating and registering a symbol processor with which we collect and analyze Kotlin symbols to generate some Kotlin code. To create the processor, we start by implementing the symbol processor interface. And by the way, most things in KSP start with a dedicated interface. Our processor usually has a few important properties, such as a code generator to create files, like Kotlin files, a logger to log whatever we might need while KSP is calling our processor, and in some cases, even the options that the developer might have set while configuring the KSP Gradle plugin. An interesting fact is that KSP does not directly instantiate our processors. We must instead create a symbol processor provider, which KSP then uses to create instances of our processors. Again, we start by implementing an interface, which expects us to implement the create method, in which we return an instance of our processor. This method gives us access to the environment in which KSP is running and allow us to extract some useful information, such as the code generator, the logger, the user-defined options, but also other things like the Kotlin language version, the compiler version, the platform, and more. Then the next step is to register our processor provider so that KSP knows how to call our processor. To do that, we add this file to our module resources under this folder. This file contains a list of the fully qualified names of all our processor providers. And a word of warning, if you are anything like me, you will eventually forget to add one of your providers to this list and probably waste hours of your time trying to understand why KSP is not calling your processors. However, I am glad to announce that we now have a better way of registering providers. So you just annotate them with the auto-service annotation, which comes from this Gradle dependency. And then there was a nice guy, I don't know him, but he did a really nice job of creating a KSP processor that actually generates that file that we saw earlier for us. All we need to do is to add his processor to our project. And when we apply the KSP Gradle plugin, we get access to this KSP function, which then we can use to provide all the Gradle dependencies that implement KSP processors that we want to use in our project. Okay, next we need to collect and analyze Kotlin symbols with our processor. And we do this by implementing the process function, which gives us access to a resolver. The resolver is our ticket into the Kotlin compiler and how we will collect the symbols. You should also know that KSP actually works in multiple processing rounds. So please be prepared for your process function to be called multiple times. In each round, this function should return a list of all the symbols whose analysis you might want to defer to another round, and we will see this later. Let's now see how we can collect symbols with a resolver. So say you want to collect all Kotlin files. All you need to do is call the getAllFiles method, and this returns a sequence of KS files, which is again an interface that represents a Kotlin file. If you are wondering why the method returns a sequence, please bear in mind KSP is focused on performance, so most of the collections that you get with KSP are lazy. However, most of the time, you actually want to collect symbols that are annotated with specific annotations. So for this, we call the getSymbolsWithAnnotation method and provide the qualified name of the annotation. This returns again a lazy collection of all the symbols annotated with that particular annotation. To be honest, I think having to provide the qualified name of the annotation as a string is a little error prone, so let's create a nicer version of this function, which instead uses the clay class of the annotation directly to retrieve its qualified name. So now this is how we collect symbols with my annotation, and we can even create other functions to help filter the kinds of symbols that we want to collect. For example, we might collect only annotated classes, annotated functions, properties, and so on. Okay, I will not go today into the details of how KSP models the Kotlin language, but I just want you to have an idea that KSP follows Kotlin very closely. So you will naturally start to understand this mapping as you use KSP. For example, you have multiple interfaces that represent the different kinds of declarations you have in Kotlin. For example, class declarations, function declarations, but other things like property declarations and more. All of these interfaces implement another interface which represents the declaration of just a generic Kotlin symbol. However, we also have other things like declaration containers. A Kotlin file is an example of a declaration container. But so that you have a sense that all of these actually make sense, if you think about it, a class declaration is also a declaration container because we can in fact declare properties, methods, and even other classes inside the class. But in the end, all of these entities are KS nodes. A KS node is literally a node in the tree that KSP builds while analyzing the source code. This is not exactly the abstract syntax tree that the compiler creates, but it is a tree of symbols that is closely based on the ASD. Well, because declaration containers are all Kotlin symbols that can be annotated with an annotation class, they also implement an interface, KS annotation, that represents just that. Well, each of these interfaces we see here provide a simple API to analyze each kind of Kotlin symbol. For example, this is the API to analyze a class declaration. As you might expect, you have access to the class kind, its primary constructor, its supertypes, which includes the interfaces that the class might implement, and also its base class, and more. If you are curious, you have here in this link the complete KSP class diagram. Just be prepared because it is a big one. As another example, here is the API to analyze function declarations. What's interesting about all of these interfaces is that they only provide you an API to analyze the attributes of a symbol declaration and not its actual implementation. For example, with the KS function declaration interface, you cannot actually analyze the body of a function. And this is because the KS prefix in all KSP types stands for Kotlin symbol. And you should really think of these symbols as just the declaration of some Kotlin code entity and not its implementation. As you remember, this is in fact one of the trade-offs necessary for KSP's simplicity. So the last step in using KSP is to generate some juicy Kotlin code. And we could have an entire session on this, but we don't have time today. So I'll just advise you to please be as lazy as possible and do not generate code manually. So use a library instead. I think that Kotlin Poet is an excellent library. It is also very intuitive, so that's what we'll be using today. And we'll learn how to use it as we go through the examples. So let's solve some real problems using KSP, starting with enum classes and seal classes. Okay, our project will be structured in two Java modules, one that contains our annotations and the other which has our KSP processors. When working with KSP, it is always a good idea to start by stating what we want. So, in this case, given an enum with some entries, we want to generate convenience extensions that check if an object is one of those entries. So, we will introduce the case detection annotation to mark the enums which will get these extensions. And since enums and seal classes are actually quite similar, our annotation will also work with seal classes. The only difference is that we will have to use the is instead of the equals operator. So let's now create the case detection process and implement the process function. We start by collecting all the classes annotated with our case detection annotation, and then we filter all symbols which KSP can validate in this processing round. For that, each KS node has a validate method, which checks if KSP has all the necessary information for all subnodes associated with that KS node. For example, if one of those nodes depends on code that we will generate later, KSP will not be able to validate that node in this processing round. Okay, then our process function just returns the symbols which we could not validate in this processing round. And now we need to process the valid symbols. As mentioned, our annotation will work for enum classes and seal classes, and even seal interfaces for that matter. And to process these symbols, KSP uses the visitor pattern, in which a KS node can accept a visitor object. The visitor encapsulates the processing logic for visiting all subnodes of a KS node. And in general, it receives at the beginning of each visit data of type D and returns a result of type R at the end. This is also why we need to provide initial data when the KS node first accepts a visitor. And then in the end, the accept function just returns the accumulated result after visiting the very last subnode. The KS visitor interface, I think, has 25 or so visiting methods to visit each different kind of node. However, most of the time, the visitors we implement don't receive or return any data and are only supposed to visit a small subset of all KS node types. So for this situation, we can instead extend of KS visitor void, which is a visitor that doesn't receive or return anything and has an empty implementation for all visiting methods, so that we only need to implement those that we really have to use. Okay, we will now implement the enum case detection visitor, and because of time, I'll let you check in the demo app the implementation for the seal class visitor, but it's again very similar. Since the visitor will be generating those convenience extensions, it receives the code generator, and because, as I said, it doesn't receive or return any data in each processing round, the initial data is just unit. To implement the visitor, we extend KS visitor void and only need to implement the visit class declaration. Here, we'll extract each enum entry and map it to the convenience extension. So the entries of an enum are actually declarations within the enum class declaration. They're also of type KS class declaration, but their class kind is enum entry. And once we have the entries, we need to start generating some code. As I said, for that, we'll use Kotlin Poet. So some Kotlin Poet 101 for you guys. Kotlin Poet uses the builder pattern extensively. And each kind of Kotlin entity, such as file, function, property, and so on, is represented by a spec. And to create a spec, we need to use a spec builder. And that's pretty much all that we'll need for, all the Kotlin Poet that we'll need for today. So we will need a file to all the code that we'll generate, and we'll start with a file spec, and we'll create it with a file spec builder. Then we'll add the convenience extensions, which are the extension properties. So we call add properties, and we'll provide a collection of property specs, which we will map from the enum entries. And then we just need to build a file spec and write the code to a Kotlin file using the code generator. We also provide a flag to help KSP handle incremental processing. In this case, the output file is only going to be affected by a single input file, which is the file where we declare the enum. This means that our processor is what we call an isolating processor, so it just means that we can set the aggregating flag to false. To create the builder, we only need to provide the package and the file names. The package name will be the same of the enum, and the file name will just be the name of the enum with the case detection suffix. Then let's finish our visitor by creating the property specs for the convenience extensions. Okay, we'll map the enum entries to property specs, and because these are extensions, we need to add the enum as the receiver of the extension property, and we'll also need to add an implementation for the getter. To create the builder, we need to provide the name of the property, which is just the name of the enum entry plus the is prefix. The type is a Boolean, and then we make sure that the extension has the same visibility of the enum. So if the enum is declared as internal or public, the extension will have the same visibility. Okay, to add the receiver, we just convert the enum class declaration to a Kotlin Poet class name, and then we implement the getter using a getter builder. For this, we only need to provide the code that does the entry checking. And also note that we can use this placeholder to interpolate the enum entry. We only provide the entry as a Kotlin Poet class name to Kotlin Poet, and Kotlin Poet does interpolation for us. Finally, we build the getter, and that's it. We are then solving our first problem for the day. Let's now move on to the main course, where we'll create some view models that play nice with Compose. In this problem, we will use Coin for dependency injection, and we will use pure MVVM, so we won't be dealing with things like UI state, data classes, and so on, just for simplicity's sake. So imagine you are creating a weather app that shows weather details for various locations. You probably want to start by showing an overview of the weather for each location. So the composable for the overview might have a view model that looks something like this. And then the composable will get the view model instance using an injection function. To preview the composable, you need to override the injection function and provide an instance of the view model which is appropriate for previewing. That usually means creating mock data and using mock services or repositories. Now imagine you are building the complete details screen, which uses not only this composable, but also other composables that have their own view models. Now you're kind of in a pickle if you want to preview this composable, because you need to add parameters for each view model right in the parent, so that when you are previewing, you can override each instance with your own previewing instances. What if we could solve this problem right at the source? That is, when we declare each of the composables that inject their own view models. For this, we will introduce our custom injection functions, and these composables will also use an interface that defines the view model contract instead of using the view model directly. Of course, both the regular and the previewing instances of the view model will implement this contract. These interfaces will have the sum prefix and will be generated by our KSP processor. So the contract for each view model simply becomes an interface that exposes its public properties and methods. With this contract, our KSP processor can even generate previewing data classes so that we don't need to have the work of creating mock repositories and mock services. And this is what those previewing instances look like. Of course, our custom injection functions need to get their previewing dependencies from a previewing module. And since Coin has no concept of preview module, I added this small extension to Coin, and you can check in the demo app how I did it. This extension has its own DSL to define previewing definitions, just like Coin has the Coin DSL for Coin modules. As an exercise, you are more than welcome to create a KSP processor that generates this DSL, just like Coin annotations generate the Coin DSL, but that is, of course, another challenge. So for each preview definition, we'll associate the runtime view model type with a previewing instance. Then we also need a composable function to call in our previews so that we can provide the preview module. And finally, our special injection functions which can inject the previewing dependencies when we are running under compose previews. So let's now adapt the original composable so that it uses the view model contract and our special injection function, and that's it. Well, almost, because unfortunately the injection function is generic on the view model type and the contract type. So our processor will also generate an injection function for each view model with the appropriate type parameters so that we can simplify the call site. Now, when previewing the original composable, instead of having to provide an instance, a previewing instance of the view model explicitly, we just wrap it in our Coin preview and provide the preview modules. And this becomes truly elegant for the details composable because now we can drop all of the parameters and simply wrap it also in our Coin preview. So let's sum up what we want. First, we will introduce a previewable annotation to mark our view models, and then our view models will implicitly implement the view model contract. This implementation is implicit because we'll actually generate the implementation for the contract interface based on the implementation of the view model. So, if we add a property or a method to the view model, nothing happens to the contract. But if we add the override modifier, then that property or method becomes part of the contract. And of course, this applies to all properties and methods of the view model. And lastly, don't forget that our processor will also generate the injection function for each view model with the appropriate type parameters. So let's get going and create a processor. Like we did before, we collect the classes annotated with our annotation, However, now KSP will not be able to validate any of these classes because they implement an interface which does not yet exist, which is the view model contract that we will be generating next. So instead, we just keep track of the symbols that we visited so that when KSP does another processing round, we simply ignore them. And then we need to visit each view model with our previewable visitor. It is also a visitor that doesn't pass any data around, so we extend KS visitor void. And once again, we only need to visit the class declaration. Here, we'll extract all the properties and methods which will be part of the view model contract. And this just essentially means that they have the override modifier attached to them. Let's also create a file spec to hold our code for the contract. And then we need to add a type, which is the interface of the view model contract. And we also need to add a top-level function, which is the injection function for that view model. And then we build the spec and write it to a Kotlin file like we did before. Generating the injection function is fairly simple, and because of time, I'll let you check the implementation in the demo app. The interesting bit is actually generating the view model contract. So we'll use an interface builder, and then we add all the properties and methods that we collected in the last step. Again, adding those is fairly simple, so I'll let you check the demo app. And to create the interface builder, once again, we provide a package name and the name of the interface. The package name is the same of the original view model, and the name of the interface is just a view model name with a some prefix. And that's it. We're done with our main course, so I hope you still have some room left for dessert. And I promise this will be a sweet treat because you guys deserve it after all that we've been through. So for dessert, we have content providers. Maybe a tough pill to swallow if, like me, you don't really enjoy working with them. But let's try and add some sugary KSP icing on top and make a sweet dessert. So imagine you need to read from a content provider that publishes a list of locations. Wouldn't it be cool if we could avoid all the hassle of setting a content observer and then having to manually read all, using a cursor, all the content from the content provider columns? What if reading from the content provider was as simple as defining a model class to hold our location data, and then just calling a content observer extension, which returns a flow that lets us observe the content provider rows directly as a collection of locations. All that we need to do is to provide a contract that tells this extension how to read the locations from the content provider. And as you might have guessed, we'll be generating this contract next. Let's first introduce an annotation, the content type annotation, to mark our model classes. And interestingly, this annotation will actually hold some data now, the authority of the content provider and the path to the table we'll be reading from. We'll also assume that the column names of the content provider associated with a model property is the name of the model property just capitalized. So if we are reading from a content provider that has funny column names, we'll also introduce a column name annotation so that we can provide these mappings manually. Okay, let's now analyze the contract that we will be generating. First, we start by adding some constants, and also this contract extends an interface for reading and writing from the content provider. This interface is generic on the content type, which is in this case the location. So the constants that we'll be adding are the authority and path that we'll extract from the annotation we created, and also the mappings between the property names of the model class and the column names of the content provider. Then we need to implement the interface. And the interface has actually quite a few things in it, but these are the two most important ones. So a cursor extension to extract an instance of the model class, which is essential when we are reading from the content provider, and also a function to convert an instance of the model class to content values, which we only need when writing on the content provider. So let's create our last processor. Again, we start by collecting all model classes annotated with the content type annotation. And as in the first example, we only care about the valid symbols, so we just return the ones that were deferred to other processing rounds. Then we focus on the valid symbols, but before we can visit each model class declaration, we need to first extract the data of the content type annotation. So we call get annotations by type, to retrieve an instance of the content type annotation. And only then can we visit the declaration of each model class. Unlike the previous problems, now our visitor will actually be passing some data around between each visit. So we introduce the content type context class to hold these processing data, and I will refer to it as just our processing context from now on. And now our accept function will return the final processing context after visiting all subnodes of each model class declaration. In this processor, we don't pass the generator to the visitor because we actually can only build the contract once we have the final context, which is returned by the accept function. So we'll abstract all the code generation logic in a contract builder, which will return a file spec builder with the code for our contract. So all that it's left to do is to implement the visitor. And we now extend from KS empty visitor, which receives a processing context at the beginning of the visit and returns another one at the end. The empty visitor expects that we implement a default handler, which is used, again, by default when visiting all the various types of KS nodes. Here we'll just implement a handler that is a pass-through of the processing context. And then we need to actually override all other visiting methods that have a different visiting logic. So when we visit a property declaration, we'll just add that declaration to the previous processing context. And when visiting the class declaration, we'll collect all properties and then compute the final processing context by accumulating the context returned in each visit of the properties that are declared. Last but not least, we need to return the final processing context so that we can build the contract using our contract builder. And now that we have it, we can go back to the processor and implement the contract builder. We start again with a file spec builder to hold our code, and the package will be the same of the model class, and the name is just the name of the model class with the contract prefix. Again, we add a type, which in this case is an object, so we'll use an object builder. And the name of the object is like the file name, the name of the model class with the contract suffix. And because our contract needs to to implement the content type contract interface, we add a super interface. Also, this interface is generic, so we need to provide the model class as a type parameter. And for that, we use the parameterized by function of Kotlin Poet. Then we need to add the cursor extension to retrieve instances of the model class and the function to convert instances of the model class to content values. Once again, we have nothing new here, so I'll let you check the implementation in the demo app. And now we complete our processor by building the file spec. And that's it. We have completed our dessert. I hope you enjoyed, and this also ends my presentation. Thank you. And I'm not sure if we have time, but if you do, I'll be more than glad to answer any questions.
I have a question. Is it possible when we are observing two content providers at the same, using this pattern for observing two content providers?
Yes. So as you probably remember, when we created the annotation, the content type annotation, we added some properties to that annotation, which define the content provider that we are reading from. So you would have to declare another model class to provide different data for the content, another table, I guess, of the content provider or a different content provider, and then you would use that.
And does it have any effect on the speed, the speed of the reading from the content provider, or is it just about being more effortless in creating this?
This is just so that you can avoid the step of adding a content observer and then deal with the cursor to extract the data from the content provider. So I guess that you would have the same limitations that you would have when manually reading from the content provider. Thank you. Okay.
I have just one more question. So KS is going to add a lot of generated code properties to the project, right?
Sorry, can you speak?
It's going to add a lot of generated code to the project.
Up to
Right.
you.
Yeah. So have you ever checked or noticed that in a big project, if you want to continuously use KSP, is going to add a severe, compiling time to the project, and it's going to affect.
I, yeah, I get your question. And even though I'm giving a session on KSP, I do not advocate that you just replace a developer for KSP. That is probably not likely going to happen. We use KSP usually sparingly whenever we have boilerplate code that needs to be there in the project anyways. So what I can tell you is use your own judgment. Also, something that I did not add to this session, but it's part of the demo app, is how you can do testing while developing KSP processors. And again, I am not an advocate for TDD, but I think this is one of those scenarios where TDD is actually very helpful. So the idea would be to use a testing framework. I think it's called Kotlin compile testing, and you have an example of some unit tests in the demo app. And basically, you start developing or adding features to your processor as you implement the unit tests, because it's probably the easiest way, instead of going by trial and error and adding something to your processor and then generating the code and then trying to understand what went wrong. So you have some, that's also why I said that we should always start by stating what we want. So we solve a simple problem manually. The human always does the work first, and then we use that as the standard for our processor. We use it in our unit tests, and then when we add a feature to our processor, we make sure in our unit tests that the processor is generating the expected code. All right, if there are no more questions, have a nice Droidcon.
Thank you.
Cool. I think we'll get started then. Hello, everyone. Good morning. Hopefully you're in the right room. A lot of you have been sat here for a few minutes, so if you're not expecting this talk, then I don't know what you were doing. So hopefully you are in the right place. This is my talk on how to stop the Gradle snatchers. I talk about security, I talk about mobile security, and kind of how we can use some security tools within Gradle to improve our build processes. To kick things off, who am I? My name's Ed. I'm from Nottingham in the UK. I'm a lead Android dev at a company called ASOS. ASOS is a fashion company. It might not look like it, but I do actually work in fashion. So we sell clothes all over the world. I'm also an Android GDE in the Android profession. So I talk all over the place in many different conferences around the world, mostly about mobile security. I love talking about mobile security, but I'm not an expert. I'm just an enthusiast who wants to kind of pass on the knowledge I've learned over the years. I'm available on social media. I'm available on all good social media and Twitter. So please do check my handle. It's down the bottom here. You can also go to my website at the bottom, spaghetti.dev, for more information. And this is actually my first time in Lisbon. I've never been here before. Been to Portugal before, but Lisbon's wicked. I'm coming back. So hopefully I'll see you next year. Let's kick things off then. Supply chain attacks. What is a supply chain? What is a supply chain attack? Well, a supply chain attack is an attack on your tooling which aims to introduce vulnerabilities or malicious code without being detected by you, the developers. So this is kind of a part of your kind of maybe build process, or it's not they're attacking your application directly, but the processes that are involved in building it. So this talk is basically going to be a talk about how we can kind of avoid those situations and ensure that supply chain attacks don't happen to you, with the particular focus on Gradle. So without further ado, some of the things we're going to look at today, we're going to look at a couple of real world stories of where supply chain attacks have affected people and Gradle specifically. We're then going to look how we can secure our dependencies. I'm sure we all have dependencies. So Gradle has a few tricks and tips on how to improve that process. And then we'll talk about securing the tool itself, Gradle. How do we make Gradle secure in our apps? So without further ado, let's now talk about the elephant in the room. Gradle. Can I have a show of hands who uses Gradle at the moment? Everyone. I think that was everyone. Fantastic. So Gradle and Android have had a history for quite a long time. Let's quickly revisit the timeline of history we have with Gradle. There was a time before Gradle. I'm sure many of us remember these years fondly. When kind of Android came about in the sort of late 2000s, we didn't have Gradle. We had Ant. We had the Android developer tools. And it was I'm sure we all have very fond memories of those times. Again, hands up if you've been doing Android since then. Yeah, I can tell because you're the ones with the grey hair and the bags under your eyes. Yeah, I know, I was there too. However, if you weren't there, it was basically colloquially known as the Dark Ages. We had Eclipse, we didn't have Android Studio, we didn't have Gradle. It was a painful time, but it was a good time. It was important. We learned a lot from that. The good thing was, in fall of 2012, we started to see that Android was moving in a new direction. We got the very first V1 or V01 of the new build tool. At the time, it was called the new build tool. What that eventually evolved into was Gradle. So if we fast forward all the way to version 1, it took them a couple of years, but we got to the initial release of Gradle 1.0 or AGP 1.0 in 2014. So that feels like a very long time ago, and that's because it is, because now, present day, 3 days ago, I think AGP 8.6, I think, was released. So we've come a long way, basically, is what my point is. We've come a long way. Gradle has been with us now for over 10 years, and we're fairly comfortable, mostly, in using it. But I want to talk about I want to go through a couple of examples of stories that have happened kind of along this timeline. And one of the really, I think, key ones that I like to talk about happened in 2018. Some of you may know this story. But the story is called A Confusing Dependency. So this story involves Martin. Now, some of you may know Martin on a side project where he was creating an offline tool. This tool, it doesn't really matter for the purpose of the story what it did, but the important thing to note is it was offline. So, like any good developer, we occasionally need to get tools and third-party code from elsewhere. He found something that met his particular use case. Again, the library doesn't really matter in this story, but he fetched a dependency from Jetpack. I'm sure we all fetch dependencies every day in our project, and this should be no difference. So Martin had a specific need and went and fetched a dependency. However, when he ran his code after this dependency, something strange happened. Now, normally, I get this when I've forgotten to do something at the start of the app, but Martin was quite surprised. This dependency should have been an offline dependency. There should be no need for an internet permission. So what was going on? Very strange. What Martin did was take a look at his Gradle configuration. And again, this may look very similar to a configuration you have in your own app. And he decided to figure out where this dependency was being resolved from, because it couldn't be being resolved from the Jetpack, because he knew what that dependency was. He could see it was open source. He could see what that code was doing. So the way that the repository block works in Gradle is it sequentially looks for dependencies line by line. So it would first start off looking for this dependency in the Google repository. Does the dependency exist there? No, it doesn't. Of course it doesn't. He then went to JCenter. We all remember JCenter, right? It's not around anymore, but at the time it was. Well, it shouldn't exist. So let me introduce the new actor into this story. Fake Wharton. You may look like somebody you already know. What has happened in Martin's case was a malicious actor had pretended to be Jake Wharton on JCenter and actually uploaded a version of the dependency Martin was using under one of Jake's well-known libraries. So what this user had essentially done was created a new repository full of libraries which were very common to use, but had shadowed them with malicious code within them. So this was the problem. What had happened was this Jake Wharton, this fake Jake Wharton, note the 2 A's, had supplied this dependency from JCenter, and yeah, it contained malicious code. And Martin had no way of knowing this. So I think the long story short here is what you really need to know is, first of all, we're glad JCenter's gone, right? JCenter was a mess. That was a Wild West, so that's gone. But you should also trust nobody. So there is a very, very good write-up of this story that I would highly recommend you read. Martin has got it on his own site, but I linked to that in my own site, so please do check that out. So this was a very frustrating and potentially in a live application, not a pet project, a really devastating thing to happen. Importing a dependency and getting code you don't expect and having malicious users being able to upload their own stuff and not being able to check that is, really scary and something that should hopefully be making you sweat a bit. So let's quickly talk about dependency verification. We'll talk about how do we verify that the dependency is what it says it is. So we can do that 2 ways. We can, first of all, check, is the integrity of my dependency compromised? I.e., are the files that the dependency pulls down the ones I expect? And then we can also check, is the origin compromised? So was it published by the expected author? And that's also known as the provenance. So if I say provenance, we're talking about the origin. We're talking about, is it coming from a legitimate place? Well, the good news is, and the reason we're here is because Gradle offers a solution for both of these points. The first point being checksum verification, and the second being signature verification. So checksum for integrity, signature for provenance. We'll go through both of these right now, and we can discuss how that works. So checksum verification. A checksum is essentially a hash on a file, and a hash on a file, you can compare against a known hash to determine whether or not a file has been changed. If you modify a file, even if it's a single byte, the hash will be completely different. So the idea is you hash files, and you're then able to kind of determine whether or not a file has been compromised. There are some common algorithms to use. You don't really need to know about all of them, other than there are kind of 3 common ones, MD5, SHA-1, and SHA-256. MD5 and SHA-1 aren't really fit for purpose anymore. I mean, MD5 I don't think has been fit for purpose for quite a while. And SHA-1 has also been proven to be broken in 2017. And this is because you can have what is called hash collisions. You can create a malicious file in a way where the 2 hashes can be the same. So SHA-256, for now, is the best solution when it comes to checksum verification. In the future, with quantum computing and all sorts, I mean, yeah, that's a whole nother conversation and for another talk at another time. So let's quickly just have a quick look just to prove my point. If we, in the command line, create a new hello world file, we can use SHA-SUM, which is a common command line tool, to kind of output the SHA. The first example there is SHA-1, we don't really want that, and SHA-256, which we probably do. So if we had a file containing hello world and we wanted to compare it against another file to see if it's the same file, we could check that SHA at the bottom. So how do we set this up in Gradle? The task, yeah, so essentially what we want to do here is run this Gradle task. This Gradle task writes metadata for all dependencies in your app. If you run this task, if you note at the end, there is an optional task. I'll talk about that in a second. But if you run this without the task at the end, what this will do is take your default configuration and generate the SHA-256 of all the dependencies. You can add a task at the end. The task parameter is optional, but if you have different configurations, maybe you have a debug version of your app, maybe you have a release version, or maybe that you fetch different dependencies on different configurations, you can add an optional task at the end, and this will run the dependency kind of SHA-256 on all of those dependencies. So what does that actually do? I mean, that's very nice. I've shown you a command you can run, but what does it do? The answer is it creates in your project root a new file in the Gradle folder. It's called verificationmetadata.xml, and what that file contains is XML, and unfortunately it's XML, and I don't like XML. We're all past XML as Android developers now, aren't we? But yeah, unfortunately it's XML. And at the very top, you can kind of see the configuration. The configuration here is just saying that we are verifying metadata. We'll talk a bit in a second about the signature verification, but for now, because we've run this command, we're verifying the metadata, and we're going to get a list of components. If we take a look at components, so in this example, my application had the legitimate version of Timber from Jake Wharton. You can see it for each artifact, it has not only the name of the artifact that has been pulled down, in this case the Android AAR file, but also the SHA value for each one of those. So how this actually works in the background is quite simple. If you've ever kind of seen a raw Maven repo, they look like this. You have a whole bunch of files, you have a whole bunch of dependencies that you can pull down. So if you look towards the bottom of the screen, hopefully it's big enough for the people at the back, but there's a whole bunch of AAR files, and each AAR file has a known SHA-256 and SHA-512 even, like a file that goes along with it. So what happens is Gradle will pull the repository, get the dependency, and then add those values from the Maven repo into the Gradle XML file. So now, when you've run this step, if anything ever changes, if you ever were to then pull again your files and the dependency and something has changed, for example, maybe in this case, there's a discrepancy between the SHA and the actual file that's been pulled, you would get a compile error. You would get an error that's telling you dependency verification has failed. So this is a really important bit of tooling that can be used to stop dead any code being kind of pulled into your application that would otherwise kind of make its way in. So you can use, when you run this dependency verification, be able to get this to this step, very, very quickly, which is great. However, to kind of get this output, you do also need a Gradle property. Otherwise, your build will fail and not a lot of output will be there. So you do also need this property as well to be able to make sure that you can kind of get this verbose output to see what has gone wrong. Again, there is also kind of different ways of reporting this. So there are other kind of, I think, flags you can provide. So you can also get this as a HTML output if that is what you're after. So to kind of confirm, we would first run a list. When we've kind of got to a point where we're happy with our dependencies, we know what they are, we can manually kind of run the Gradle command. It will pull all of the SHAs, and then going forwards, we should be safe in the knowledge that those dependencies are safe. We'll talk more about that in a second. So the next thing I kind of mentioned was signature verification. So when we upload dependencies, we are often uploading them to public Maven repos. The most common one, I guess, being Maven Central, and they often require signed artifacts. Now, the artifacts are signed using something called the Pretty Good Privacy Standard, PGP. And developers must create kind of a cryptographic key pair to be able to kind of sign their artifacts, to essentially assure that they have been created by the person they've said they've been created by. These public keys, so the private keys are kept obviously on the user's side who's created the dependency, but the public keys are published to a public key server. I believe Maven Central has about 2 or 3 different kind of key servers that they support, but I think for the vast majority of them, it tends to be the MIT key server that's kind of used for this. So you use the PGP standard. It's actually quite confusing. PGP is the standard, but you use GPG to sign the keys. So I always get that the wrong way around. Hopefully I've got that the right way around this time. But yeah, essentially you sign the artifacts and upload them to a Maven repo. So when the dependency author has signed them, how do we then verify that the dependencies they've uploaded are the ones we've downloaded? Well, we use another step within the previous command that we've seen before. So in this case, write verification metadata SHA-256 before, which was the dependency verification, and the PGP, which is now the author. What this does is very similar to what we saw before. It turns on the specific flag in your config, and then you also get a list of trusted keys. These trusted keys are the essentially IDs and hashes of the keys that have been pulled down locally and then compared against the library author. So in this case, this ID and all of this references Jake Wharton. So again, a visual representation of kind of how this works to hopefully kind of shore things up a bit. In the Maven repo, again, what happens is that we pull the ASC file. The ASC file is a kind of PGP signature file that's kind of associated with verifying the identity. And that comes along with the artifact as well. So each artifact has this ASC file along with it. And then here's an example of how this would work in real time. So in this case, I'm getting the GPG verification on a particular file. It's failed because I don't have the key for Jake Wharton locally. So Jake has helpfully put it on his website, so I can pull his public key, and then I'm able to verify locally, manually, kind of that the file is from who it says it is. There we go. It takes a little bit of time, but that is essentially how you would manually do this. But this is what happens behind the scenes. Gradle is doing this automatically for you, so we're verifying that each file is from the right person. But if you wanted to verify this manually, this is exactly how you would do it. So yeah, hopefully that makes sense. So there are pros and cons, as with everything, to this process. The very first thing is that you get trust in your app's dependencies, which at the moment you might not be in a place where you do trust your dependencies. If you're pulling dependencies every day, how do you know that where they're coming from? How do you know they are what they say they are? At the moment, you probably don't. Gradle is also flexible in kind of the levels of verification you wish to use. So you have the obviously the dependency verification step and then the signature. So you've got the origin, and the kind of integrity as well. You can be more hardcore, or you can kind of depend on your own needs, which kind of steps you use, whether you use one or both. Supply chain attacks are also mitigated. So supply chain attacks, as we kind of talked about, is something that we don't really think as developers. We don't really think about kind of, if we see an attack surface, the attack surface for us usually feels like the app. No, this goes beyond this. This is looking at making sure that we actually secure our tooling as well. And obviously by doing this, you're going to sleep a lot easier at night, and so will I, because I know you guys will be doing the right thing. But there are cons. There are always cons. This is really not a frictionless process. This is something that is quite frustrating. And when you are starting this process, you must start from a point where you trust all the dependencies. So if you were to run the scripts and the things that we've just looked at, you would need to, at this stage, manually verify every single thing and make sure that you are happy that you are starting from a point where you have complete trust. If you don't, then there's no point doing this. Because if you are not trusting the dependencies that you're downloading already, there's no point verifying that you're downloading a bad dependency. So my point is if you're going to do this, which I recommend you should, take the time to do it. Another bad thing is obviously it's XML. Had to throw that in because I'm sick of seeing XML. And yeah, actually the simplest solution for most developers, if you don't want to introduce problems with dependencies, is to ship with no dependencies, which sounds crazy. But a lot of high secure environments, banks, healthcare industry. A lot of they try and minimize dependencies. So maybe shipping with no dependencies might be difficult, but maybe shipping with fewer dependencies might be a good idea. Yeah, there's another step we can do as well. So this one isn't really kind of well, I suppose it is a security tool in some sense. It's repository filtering. So some of you might have seen this before. Gradle has the ability to kind of filter which packages can be fetched from certain repos. So for example, making sure that only Google dependencies are coming from the Google Maven repository. And making sure maybe, in Marton's case, a really good example would have been Marton adding it to a dependency filter to make sure it only pulls from Gitpack. There are rules that Gradle provides to kind of include and exclude dependencies. It's very, very straightforward, as we'll see. And it works for dependencies and plugins. However, if you are using Gradle 7.0, there is a bug, and you need to make sure that, I think that you need to, well, sorry, if you're not using Gradle 7.0, you need to make sure you are, because there is a bug prior to that. So yeah, please make sure that if you are doing this step, you're using Gradle 7 and above. But yeah, maybe a visual example is a little bit better here. So in this case, we might want to fetch certain dependencies. You can, again, kind of filter it by group or by module, or exclude by module, or exclude by regular expression. There's quite a lot of modifiers here that you can use. And in this case, yeah, we would be fetching things from com.example, a specific module, com.example.foo library, for example. And yeah, you might want to exclude all libraries by me. I don't know, maybe you do. So that is how you would do that. And the benefit of this is making sure that you gain the trust that your dependencies are coming from the right source. The ordering issue that we saw before, making sure that, going line by line, checking Google first, checking Maven for JCenter first, that's eliminated, right? Because if you have a complete set of rules, you would make sure that you are, you're always fetching from the right place. So you can kind of do this as complex or as simply as you like. And the other benefit, which is also not really talked about as well, is that you also don't leak your dependencies. And what I mean by that is if you're calling, for example, to a Maven repo and trying to fetch dependencies that don't exist, you are still pinging that Maven repo with a request. And that request is telling that Maven repo, hey, I'm looking for this library. I'm looking for that library. And if you had a malicious, I don't know, if you were feeling really sneaky and you wanted to create a malicious Maven repo, hey, you could ping and find what people are trying to search for, and then maybe, create your own kind of vulnerability based on that. So yeah, repository filtering is another kind of addition that you might want to add to your, to your tools. So that was, again, a very, very quick overview of the confusing dependency. Now I want to talk about something that happened not too long ago, a couple of years ago, the wrapper exploit. This one was a fun one. Here's a question, you don't have to know the answer, but think in your head, where's a great place to see hacking in the wild? If I wanted to go see somebody really pushing the boundaries of hacking, where would I go? Well, I'll spoil it for you. The answer is, of course, Minecraft. A lot of people on Minecraft, for whatever reason, just want to hack each other. For a game that is very peaceful and very something I find quite relaxing, there are a lot of people intent on causing other users a lot of harm. So this story, and I promise this is relevant, concerns a Minecraft server. And back in 2022, MinecraftOnline.com was the biggest and oldest, maybe not biggest, but certainly oldest multiplayer server in the world. It had 290,000 unique players. I think the fun fact is it opened 1 hour after multiplayer functionality was added to Minecraft. So it's been around a while. And all you really need to know about Minecraft and why this is tangentially related to what we're talking about is that Minecraft servers use plugins. And these plugins are JVM language projects, like Android. And Gradle is the build system used, like Android. So this does work. I do promise this is relevant. What essentially happened was, there was a banned player. A user was, I don't know what they were doing, something malicious. I think they were trying to hack somebody, or they were trying to sell something illegal. I don't know. It doesn't really matter. They were breaking rules. I think it was distribution of malware, actually. So yeah, they were being pretty naughty. And over a period of time, what they did was they became a totally legit player. They reinvented themselves. They came back, oh, I'm somebody else now. I'm somebody, over a period of time, I'm someone, I don't know that guy. Who was the previous guy? And what they ended up doing is getting in and socially engineering themselves into a position where they became a totally legit dev team member. So, I mean, there's holding a grudge, and then there's this dude. He was really searching for vengeance. So he socially engineered himself into a dev team member and helped on some of the plugins, and one day just made this commit. Yeah, just this. Nothing wrong with that. Can't see anything wrong. If I was doing the code review, looks good to me. Perfect. Totally fine, right? However, what he'd actually done there is distribute a modified Gradle wrapper jar file. Now, this is something that sits in all of our projects. How often do we think about this file? I guarantee you, never. You're thinking about it right now, but that's only because I've just mentioned it. But never, right? This exploit he had written was only written to be exploited on the CI. So he'd done it in a way where, you know, he could execute code, arbitrary code, when the CI was run. So yeah, essentially the attackers what he did was he created this malicious jar file, uploaded it to CI, and then got to a point where he was then able to kind of execute commands directly to the server. So he was able to give himself really good items. I don't know if that's any good, but he was also able to access the Linux operating system that ran the server as well. So that's a lot more scary than getting some good items. And essentially what he did with this was just cause absolute chaos and havoc on this server. However, this was actually the first time that was publicly documented where we had seen an attack on this kind of surface, on the Gradle wrapper jar file. And this is a really good example of something that you might need to think about going forwards, especially if you work in open source, especially if you work in a large company where many people have access to your code base. This is something that you might want to implement. So how the hell do we prevent this? Well, like I said, this was the first public supply chain attack on the wrapper. And there is a way of verifying the wrapper's integrity that can prevent this. You can also verify the Gradle binaries themselves. That's another good step. And for what it's worth, all of the hashes of the wrapper and distributions are always available on Gradle's website. So there are tools, and if you wanted to do this step manually, you totally could. However, we don't want to do it manually, do we? We want somebody to do it for us. And helpfully, I've done it for you, partially. I've created a wrapper verification script here. It is just simply a shell script. You can get it off GitHub. And what this will do is it will check that your wrapper file and wrapper jar are the expected values for your version of Gradle. So in this case, I've done it on Gradle 7.6.1, which is quite out of date now, but this talk's been around a while, so I apologize. And yeah, this is something you can run yourself. However, there is something slightly better than this. I made this for myself and then realized, oh, they've done it already. They have done it already. So if you use GitHub, this is probably the better step, and obviously supplied by Gradle themselves, so I would highly recommend using this. It is simply a GitHub action that you can add to your pipeline today, and you can probably do it right now on your phone whilst I'm talking, although please don't, because that will be distracting. But you could definitely do it after the talk. And what this does is exactly the same as before. It just basically verifies that the Gradle wrapper jar is the one that it expects. So nobody can then kind of, hack your Minecraft servers, I guess. So what are the pros of kind of verifying the wrapper? Well, it's way more straightforward than kind of not verifying it. It's, you definitely don't want to be leaving yourself vulnerable, especially when something can be as slipped into a regular commit without being noticed like that, potentially. You can definitely do this very quickly, so it's something you could probably do before I finish the talk. This is something that you can fit into most CI pipelines, so even if you're not using GitHub Actions, you can use my script or write your own, and it's something you can implement, again, in probably about 5-10 minutes. And yeah, GitHub gets it for free, so you might as well add it. There are cons, the main con being still fairly unlikely anybody's going to attempt to attack your Gradle wrapper jar file. Otherwise, I can't really think of any cons. I think it is an unlikely attack vector, but it's one that you need to be aware of. So for the sake of adding something for 2 minutes, it seems pretty worthwhile to me. The next thing we can do is verify the distribution. So you've probably seen this file many, many times. It is the Gradle wrapper properties file. It contains the URL of the distribution of Gradle that you're using. And what happens is when you run Gradle for the first time, it pings this URL and pulls down the Gradle binaries for you. However, how do we know that the binaries that we've pulled down are the legit ones. How do we verify it? Well, I'm glad you asked, because there is something called the distribution SHA-256 sum. And this is a property that you can add to your Gradle wrapper properties file that will check the binary when it's pulled down against this hash to make sure that they match. And essentially, again, if you're ever kind of updating your wrapper properties file, this is a value that you can pull down from the Gradle website and add to your file. However, don't do that, because you shouldn't be editing that file manually. You should be doing it via the wrapper command. So please make sure you are verifying the distribution correctly, and that is by running the wrapper command with your version of Gradle and adding the flag Gradle distribution SHA-256 sum with the long SHA-256 value that's relevant to your Gradle version there. The other thing you need to remember as well, and this is very confusing, and I wrote a blog post about this because it also confused me, is that you need to run this twice. It's a weird quirk of kind of running this wrapper, but make sure that you run this twice because the first time, I think, make sure that it pulls it correctly, and then the second time, I think it also does the verification. So make sure that you run it twice. And what happens, I guess, if you don't, is exactly what you'd expect to happen. You fail at the time when your binary is pulled down. It's very difficult to see, I apologize again, but essentially what that's doing there is checking against the expected checksum and the actual checksum and failing. So yeah, again, it will stop your build in its tracks to make sure that, yeah, you're not pulling anything down malicious. So again, 20-second, 10-second change that you can add and add an extra level of security, and there are really no trade-offs here. Like I say, the pros, guarantees integrity of your Gradle distribution. So 100% do this, simple to set up. We've just seen how to do it in 10 seconds. It's one command run twice, and verification is very quick. It adds practically no time to your build time. So again, very worthwhile doing. However, there are cons. Yes, remembering to update the wrapper via the wrapper command and then doing it twice. Again, can't really think of any other cons. So if there are any other cons and you know them, let me know. But otherwise, again, something you can set up very, very quickly. But how do we verify the Gradle W file? The Gradle W file is the script that's run, essentially the wrapper to run Gradle. It's very overlooked. It's a bit of a shame. There is no official process for verifying this. You can roll your own solution. It should be fairly straightforward. You basically need to just have a thorough PR process at the moment to kind of verify that your Gradle file, Gradle W file has not been modified. But you can do me a favor, and that is by starring this issue or giving it a thumbs up on the Gradle repository to try and get some official solution here. Now, I think the official reason that they don't want to do this is because some people modify their Gradle W scripts. I don't know if anybody does. I've never done it, but apparently some people do, and they are worried that adding kind of a verification step might cause some friction. I think if it was an opt-in kind of solution, then it would be better, but okay, whatever. So in summary, let's kind of recap what we've seen. The Gradle supply chain attacks are very, very rare. They do occur though, so it's not something that we can totally forget about. You should definitely consider using dependency verification. It's something, again, that I've hopefully proven is something you can set up very quickly, something that will be certainly of benefit to you in your application. You can definitely use repository filtering even, just to make sure that you are pulling from the right place. And then verify your wrappers. Wrapper verification, as we've seen, is a step, and you can add it to your your GitHub repo very, very quickly. And then you can also verify your distribution. We've kind of also seen the steps there. But I hear you. I know what you're thinking. I want to learn more, probably from somebody that knows a little bit more. And there is a really great talk by Cedric from Gradle. He did that in DevOps 2019. So it's a little bit dated, but the points are all still relevant. And actually, a lot of this talk has unfortunately pulled quite a lot of information that can be found already on the Gradle security documentation. For documentation, it's actually really well written, really interesting. Highly recommend you take a look. We're not at Android makers, obviously, because I did this talk at Android makers. There are no humans from Gradle here, unfortunately, I don't believe. But there are plenty of people online and people to reach out to, so apologies that I forgot to take that out. But again, if you were asleep, if this wasn't something that was, you didn't feel like this was a bit too fast or a bit too slow or not quite right, this talk is actually now also available as a blog. So you can read it at your own pace. I've got all of the examples there. You can find this on my website at spaghetti.dev. And yeah, I would highly recommend this as kind of a follow-up and something maybe you can send to your team and say, hey, I watched this really awkward English guy give a talk, and yeah, he's got a blog. Cool. I have got a real special treat for you today. One-time offer. It's the Droidcon Lisbon 2-for-1 offer. I am talking again today here in a couple of hours' time. So please do come along for that. What we'll be talking about in that talk is nothing to do with Gradle. It's actually to do with how to keep your API keys secret in your app. If that's something you're interested in, come along. You're going to be my guinea pigs because I've not given that talk before, so hopefully it goes better than this. We'll see. Again, all of my stuff is available online. Please do check out my website. I would really appreciate any kind of thoughts and feedback on it. So yeah, do let me know. I'm on, like I say, on all socials. And yeah, thank you very much for having me. I've really, really appreciated being invited here. And yeah, thanks for coming. Thanks. I will stick around here at the front for questions, but I'm very aware that this room is boiling hot. So if you need to go out and get a drink or whatever, I'm around a conference. I'm sticking around to the end. So just come and grab me if you want to talk. Otherwise, I'll be right here. So yeah, thanks again.